Okie doke. Well, welcome everybody. Let me start out this week here with the week's headlines. And there's an interesting article. Pacific Gas and Electric is going to be working with General Motors to begin testing bidirectional vehicle charging. I see Tony nodding his head saying, yeah, you probably heard this one. My understanding on that is they're looking at it as a virtual power plant type situation. Testing is going to begin this summer, so the summer of 2022, and GM is estimating by 2025 they'll have 1 million fully electric vehicles on the road in North America. So you start seeing these things incorporated as virtual power plants. It's definitely a game changer. Underwriters Labs and the National Renewable Energy Lab are beginning work on cybersecurity for distributed energy systems. So it occurred to me when we were just speaking of Ukraine, and you know, first thing they go to is the power plants, and that's distributed energy provides a obviously more distributed target there. But currently within the equipment manufacturing, there is no cybersecurity protocols that are built into this equipment. So since everything's connected up to the internet, I suspect this is going to be a big deal where you're going to want your distributed energy system secure. SEMA, which is the Solar Energy Manufacturing for America Coalition, is proposing a number of domestic tax laws and provisions. And what they're looking to do, we've talked in the past about tariffs. Well, these are tax credits for domestic manufacturing of solar panels and solar cells. So their proposal is 4 cents a watt for the manufacturing of cells and 7 cents a watt for the manufacturing of panels domestically. They claim that at the moment there's only 8 gigawatts of capacity. I assume that's annual production of capacity in the US, 0 capacity for cells. And that if this legislation goes through, they're hoping to increase that to 30 gigawatts, which they claim would meet 100% of the needs, the domestic needs for domestic solar installations, creating 30,000 direct jobs and 100,000 indirect jobs. So,
Jay, what was the price again?
Pardon?
What was the price? I'm just curious. What was the pricing again?
It was 4 cents a watt for the cells, okay. 7 cents a watt for the modules.
So like $40 a kilowatt.
$40 a. Yeah, well, if you think about currently it's 28 cents a watt or so wholesale for a module. Okay. You know, maybe it's gone up a little bit because of supply chain. So let's say 30 cents. So they're looking to tack on a 7 cent, which would seem to me to be comparable to the 25% import tariff. So essentially they're getting their bread buttered on both sides. You know, let's charge those people when they import, and let's subsidize us when we manufacture it. And it's gonna create all sorts of jobs. I guess I'm a little skeptical on that, in that I heard this all with the natural gas industry, creating, you know, a quadrillion jobs in Ohio because of the natural gas boom. And I saw like almost none. So I suspect it'll create some jobs, but it's a huge, it's a huge thing. We'll wait and see if that happens. I don't know. I mean,
we're in Appalachia. There's not much gas there. Don't worry about it. It's all other places.
Yeah. Well, we'll see. We'll see. In the legislation front, there was a March recap that I thought I would recap. The Indiana passed Senate Bill 411, which provides local control to utility scale projects. That seemed to be a compromise measure where I guess statewide they were trying to restrict them. The locals said, hey, if we want them, we should be allowed to have them. And that's where they came down on. Virginia had passed a community solar legislation. It was a bipartisan bill that would promote community solar projects, basically subscriber-based solar arrays. But a provision within that bill said that there would be a minimum charge or a minimum bill that would be used by the utility to recoup the cost of administration and grid access. So the people overseeing this have come back with a $55 a month minimum charge for every subscriber to every solar community solar project, which would make it the highest access fee in the country. And advocates for solar are saying it basically kills the whole program. So we'll see where that falls. Wisconsin, they're still moving forward with that, prohibiting EV chargers, charging stations from getting their power anywhere but from the grid. So if they want to sell the power, and I think this doesn't really apply to homeowners, it applies to people who want to commercially sell charging services. I don't know about fleets, though. I'm not quite sure about that.
I would think that's because they lose the gas revenue taxes. So
no, it was really pushed through by the utilities. You know, they're afraid that that these things are going to, you know, it's a competitive thing, but also legitimately there's some concerns there. You say, what is a utility? If I'm producing power from a solar array and selling it through a electric vehicle charging station, I'm basically selling power. And am I now a utility? And if so, don't I fall within the regulatory framework of a utility? Well, you can get around that through two different things. You can either sell power by the minute, which is what they were doing, but that doesn't tell the customer what they're getting because they don't know how much power they're getting by the minute. Or you can say, okay, you can resell this power, but the key thing there is reselling. You're buying it from a regulated utility, marking it up and reselling it. So that's where they're coming from there. New England, this was an interesting one. This was something I wasn't ever aware of, is apparently there's what they call the New England Power Pool Committee that purchases or sets the guidelines for purchasing for a number of utilities in that region. And what they have invoked is a minimum offer price rule, which basically says based on fuel source, if the utilities are purchasing power from through a power purchase agreement, there has to be a minimum price. And these minimum prices are set in a way to promote the adoption of fossil fuel sources and to go against or to retard the adoption of renewable energy. In fact, the minimum prices are 2 to 10 times what the base residual auction. So when people tried to sell power unrestricted by these minimums, they were coming in at prices 2 to 10 times lower than what the required minimum is for renewable energy. So it basically discourages the adoption of renewable energy, makes it less cost competitive against fossil fuels in that New England area. They were supposed to get rid of that rule in 2023. They had agreed to do it. Now they've extended that to 2025. So that's the bad news up there. Shifting to a little bit of interesting good news, Primergy Solar is breaking ground in Nevada on a project they're calling the Gemini project that's located near Las Vegas. I had not heard about this, but this is a massive solar field, $1.2 billion project. It will incorporate 1,416 megawatt hours of storage, 1.8 million solar panels, and it will encompass 6,500 acres of federal land, generating enough power to power the entire city of Las Vegas from this solar array.
Are they leasing the land or are we giving it to them for free? Just curious.
my guess, probably pretty close to free. That would be my
I'm
guess.
thinking two, just was checking.
Yeah. No, I agree. Subsidy, federal subsidy of a project.
Yeah.
For sure, just as we've been doing with oil and gas for countless decades. So anyway, they're claiming it's going to create about 1,000 jobs, supposed to be completed in 2023. So just a year-long project. That's interesting. One thing that they were addressing that I thought was interesting, this is a desert environment, obviously. They're looking at raising the panels high enough so that sunlight hits at least 80% of the land that's underneath those panels, so that you're not basically creating a 6,500 acre shaded environment, which would change it's going to change the ecology of the system anyway.
How does raising the panels high enough? Wouldn't it just be separating them? I mean, raising them higher, how's that? Because it's just going to cast a bigger shadow, won't it?
It'll kick the shadow sideways, so obviously sunlight can creep in, but I'm sure you're right. There will be gaps between the rows, and my guess is this is going to be a tracking system. Normally these big systems are east-west tracking systems. So who knows? I guess you raise it up, you're going to give them some space for sunlight to get underneath. But I think, to be fair, it's going to have a massive environmental impact. You just can't cover 6,500 acres with anything and not think that you're not going to disrupt the local environment a bit. So in product news, Iguana is getting into the microinverter world, and they've announced single, dual, and quad connected microinverters, which single and dual, basically one inverter, one panel, dual, 2 panels, 1 inverter, and quad, 4 panels, 1 microinverter. So, and if memory serves, Iguana is primarily a battery company, I think. I'm pretty sure. So they're getting into that. And Solaria is increasing their product warranty on their solar panels up to 30 years. So, all right, everybody's sitting there. Am I still connected to everybody? Because that's
You're still there.
okay. Yep. I saw everybody freezing, so I wondered if it was me. A couple of things here in the webinar world. There's a community solar webinar coming up March 9th, 7:30 in the evening. If you're interested, I can give you the details on that. There's one from ASUS called Uncoupling Solar Light and Heat in Passive Solar Design, which is coming up on March 15th at 2 p.m. I am clueless what that is, but obviously it's got something to do with passive solar. So if you're interested in those, I can pass those contacts along to you. And then I also thought I'm going to be teaching next week, so there'll be no session of this next week. So I'll give you a heads up there. That's all the news I had. Do you guys have anything, any comments, any issues? Anything for the good of the cause? Looking at everything. Any word from you, Tony? I love to hear your updates on your projects that are going on.
Yeah, there's a lot we could talk about, but I think what's most timely is we're getting a lot of interest right now from China. I think that's not super surprising to us. #1 EV market in the world, a place with energy reliability problems, and a place with pollution problems, fairly significant pollution problems. So I think, the project that we're working on is pretty ideal on that side. So we're having a conversation with some pretty large players over the next week or so over in China. And then, you mentioned the project with GM. National Grid actually did a similar V2G, vehicle to grid project with the Leaf. So I think what's obviously critical to all of this is, I think this is still true. This was true a few months ago. The Leaf is the only bidirectional capable vehicle currently available, right? So now I think all EVs will eventually get there. it's mostly for like a battery warranty reason, why they're not just letting unlimited push and pull access to their battery until that gets tested out a little bit. It's interesting that GM is leaning forward on this with some of the issues that their Bolt had, but I think that that's an indication that, you know, this battery technology there's been a steep learning curve, but a lot of folks are learning a lot pretty quickly. So yeah, I mean, I think we'll start to see not only more EV used for like V2G applications, but then I think it calls into question this whole notion of just a stationary storage battery, period. Right? Like if you're rocking a GM Hummer for whatever strange reason and an EV, and that is 200 plus kilowatt hours battery pack in it, it begs the question, like, you know, maybe you don't want or need ever a stationary storage for anything. Right? So like that's kind of an interesting conversation, because the flip side is, especially with the solar, you ideally want to store it during peak hours of solar in the middle of the day when most folks are not home, so their EV will be elsewhere, right? So like that's the only interesting conversation about this dual battery kind of technology, and whether to put the battery on wheels and call that your electric vehicle or have it be stationary storage.
Well, maybe you have an insight. My understanding, like the Nissan Leaf, I think there's one model from Mitsubishi that's also considered bidirectional, and also
VW, yeah.
And Volkswagen said that by the end of this year, theirs would be bidirectional. Those are DC charging systems, as I understand it. So you're going to be sending high voltage DC from your charging station to the battery. But the Ford Lightning is looking at receiving the DC and doing the inversion, or receiving AC within the vehicle and converting that to DC within the vehicle. The charging and the inverting all takes place within the vehicle. So you're basically hooking an extension cord up, right,
Right.
to the vehicle. Do you see these automakers moving in that direction, or using remote charging stations to service a DC thing, or to keep all of that activity internal within the vehicle?
Yeah, it's a great question. So the short answer and the truthful answer is, you know, because this is like bleeding edge stuff, no, there's not a great consensus right now on what direction they're going to go with. The reason why I don't think it'll be all on the vehicle is because that, you know, I'm not going to say significantly when we're talking about a, you know, $50,000, $80,000, $100,000 vehicle, but it's a good chunk of change to enable that functionality on every single vehicle, regardless of if someone wants to use it for that application or not, right?
Right.
So to enable that functionality on all or most or whatever of that vehicle is pretty, you know, will drive the price up a little bit, right, comparatively, even if people have no intention of ever using that application, right? So right now what we're seeing is almost this chicken and egg, where the OEMs are looking at what are the scrappy pirate startups doing, and can they just go, is there a better idea there, or should they kind of develop that one solution and just, you know, mandate it across the fleet, thou shalt do this, and kind of rock and roll. You know, we could talk a little bit about, and we have in the past, about most homes, just want to make this clear, most homes aren't wired to do this right now. So
Right.
it takes it. I mean, I think that's another reason why, you know, one, OEMs are the price of the vehicle will increase. Two, it's not exactly cookie cutter because not everyone's going to use it for that. And three, a lot of the homes right now aren't designed electrically to work this way.
Yeah, as we mentioned, I know the Ford Lightning requires a minimum 80 amp circuit
Exactly.
to the charging station, and a lot of homes only have 100 amp service. So
Exactly right.
Require quite a lot. And am I right in assuming that the charging station itself, let's say we stick it in the vehicle,
Sure.
at least at the moment, would add maybe $7,000 to $10,000 in costs to that vehicle? Yeah,
exactly. So, you know, that sounds a little high. And the question is like, is that what the is that what the OEM's actually paying, or is that with a markup for kind of adding that? And there's a little bit of kind of cloud around that. But yeah, that's exactly what I was talking about. And that's a fairly significant chunk of change to be able to kind of onboard all of that. And I just think that and there's probably some personal bias on this, but I think that it just makes more sense to have that be external to the vehicle so that you can, what you need to get EVs as lowest cost as possible to maximize adoption. And then if people want to do crazy cool stuff with it, well, that's like an aftermarket, I think, bolt on, right? That I would not advocate putting in every single electric vehicle for the reasons that you just mentioned.
Okay.
Let's drop them by $7,000 to $10,000. And then if the weird ones of us who want that functionality can go buy something aftermarket and enable and unlock that.
Sure.
Is it on the Lightning because they have so much other electrical stuff that they have already that there's offering? They're set it up so you can basically run all of your equipment directly off of it. So it's got to have some amount of an inverter, a fairly good size inverter to begin with.
Yeah, I would assume that,
piece?
but also they're one of the first to market. So
Right.
So they might just be going, hey, there's no standard, there's nothing else. We'll just have to deal with this.
Yeah, I mean, what Ford's doing there is really interesting, right? Because this is true with all EVs, even the small Bolt, right? You have a huge, comparatively a massive battery, right? The Bolt 60 kilowatt hour battery.
Yep.
You're talking electric pickups, you're at 150, 180, 200, right? Same thing is true with the Hummer. So I think the interesting thing what Ford was doing is really reimagining what a vehicle is and kind of blurring what is a vehicle, what is a battery, what is a power station, right? And just kind of blurring that line and saying, hey man, we have this huge ass battery. It's on wheels so you can move it everywhere. F-150 is the working man's vehicle. So let's just enable a bunch of push and pull functionality on the energy side and see what happens, right? And I think it's a really interesting way of reimagining, not only transportation, but energy, right? It's super interesting.
Yeah. They've got enough demand, they can do it. I mean, people will pay a little bit extra, whatever the
Exactly.
Yeah.
And it's also speaking to their audience, right? So it's like, you notice none of their commercials, it's nothing about saving the polar bears or the ice caps or anything. It's like, hey, we're just doing everything that you're doing, only better. All of the stuff is like, hey, plug into our truck and you can power your tools and your home in a blackout, right? That's speaking to a very specific demographic. And I think it's a brilliantly done on their part. Because it's like it's the working man, it's the blue collar EV. It's the opposite of the Bolt. The Prius is not electric, but the Prius, right? It's like, look at this big beefy truck and look at all of the cool blue collar stuff it can do. And, scratches a lot of itches to a lot of people. I think it's brilliantly done on the marketing side.
Back in the old days, you had to put up a temporary power station anytime you work on a house, and you'd have to have that all pulled out there. The electricians come out, even after you get the electric stuff. You have to have all your batteries charged up. If you forget something, you're screwed. You're not screwed, but
Yep, and I think it'll have a tremendously positive impact on the EV marketplace because
absolutely
it will erase that red state, blue state kind of divide between getting it carried over into the EV world. So Yep. Okay, any other comments? Any comments on that or other items to bring up? I thought what I'd mention or talk about here, because I've been working on the level 2, the commercial textbook, and a few items come up occasionally. And it just occurred to me, this is one of those areas that we haven't really discussed, but integrating generators into your system. And I thought too, I could pick your brain, Don, because I know you've got oh shoot, which one do you have? Solarc?
Yeah, got Solarc, and I've got a generator, a Generac backup.
Yeah, I assumed you would. So, well, first off, okay, let's say that you want to incorporate a generator into your system. Well, the first issue is, and let's assume that you've got grid tied inverters. So this is one of those things people ask me a lot about. If my system is hooked up to the grid and I want to supplement it with a generator instead of batteries, is that something I can do? Because batteries are still pretty expensive. And I want, in case the power goes out, to supplement my array. And can I fool my array into thinking the grid is operating by hooking it to the generator? And the answer there is yes, you can, if you've got a high quality generator. If you've got a cheapy little Home Depot type generator that doesn't have grid quality signal, then your inverters may not recognize that this is an AC connection that they're happy with. And they will not operate. They won't sync up.
Yeah.
They'll attempt to sync up with your generator. Now, if your generator's output starts to dip or sag or whatever, it'd be the same as connected to the grid. If it falls outside of operational norms, then your inverters are going to shut down, or your
When it changes gear, I'll tell you from practice, I think what's going on with mine, because it'll pop out sometimes, I think it gets a fluctuation in the voltage, and I've got 3 inverters hooked up in series or in coordination, and one of them or 2 of them sometimes will pop out especially when it starts revving up.
Okay, so now let's assume that we're fine. Let's assume my generator is running and my array has synced up with it and it's running. So then what happens? We're in a grid connected situation. So now if my solar array is producing not quite enough power to meet my load demand, the generator will supplement that load demand, and everything will be fine. But what happens if the array is generating more power than what the load demand is at that particular moment?
If you're grid connected, won't it just go back out to the grid?
Yeah, but this is during a power outage where we're using our generator as our emergency backup. Now, under normal circumstances, yes, it would go to the grid, but now it's going to try and go to the generator, because so you can backfeed your generator if you do not have controls in place to stop that. But let's assume you have controls in place to stop the backfeed to the generator. Well, the power is going to go somewhere, and it will continue to increase the voltage on the system until now the generator will shut down because the voltages within the system are outside of its operating range.
Jay, let me ask, when you say that, I'm just thinking of a normal solar array. I've got an off-grid array, and when I don't need the power, it's not like a wind turbine where I need to have a dump. When I get more solar power coming in, after a certain point, just stops. And it could be middle of the day, sunny, and instead of getting 24,000 kilowatts, I get 3. That's because the batteries are full, and only so much is running.
Right.
When you said that before, I'm just thinking, for solar on that side, does the power have to go anywhere? Won't it just stop when there's not enough power when it's drawing everything it needs?
Yeah, normally
Okay.
it would in a off-grid system. But the grid tied system is designed to operate under the maximum amount of available power from the array, and then send or shunt that excess power off to the grid if possible. And if it thinks that the grid is the generator, it's going to basically create higher pressure, increased voltage, until that voltage can either burn out your inverter, burn out your generator, or simply shut down the system. So
but in most of the inverters I've seen that have grid tied and a generator, isn't there one set of wires for the grid and another set for the generator? So I would assume, and maybe I'm assuming too much, but at least on mine, I know it knows the difference between the generator and the grid. And I'm assuming that part of what it does, because it won't backfeed to the generator, but it will, so to speak, backfeed to the grid.
Yeah, I looked at the Solarc instruction manual, and it basically said, if you're going to hook up a small generator to the system, simply hook it in as if it were the grid.
If it's off grid.
Yeah, if it's an off-grid system.
Yes.
But if you're going to hook up a large generator, and I've got an image here that hopefully will sort of give people a better idea. Essentially what you'll do is you'll hook up your generator bypassing or not using your solar array. So this is the recommended way of integrating a generator. You're basically just not going to use your array. You're going to use your generator to service all of the critical loads in that situation. So that you're disconnecting in this instance, you're not connecting into, you're on this side of the transfer switch. So essentially now it's only going from the generator through the transfer switch to the critical load, and it is not connecting back to this inverter or the grid.
That seemed like a waste.
Yeah, it does.
Okay.
Yeah.
As I say, this is
Yeah, because basically what they're saying is if you want to use your array and you want incorporate batteries, avoid this whole problem. What we're trying to get away from here is, or what's motivating this discussion is there are people now who say, I would like to just incorporate a battery or a generator without batteries. And I suspect that something like the Enphase IQ8 is going to exacerbate that discussion, because they have a system now that will provide array power when they're with no battery, when the sun is shining. So that then becomes a viable option in people's minds. If you incorporate batteries with a generator, you're probably not going to have any problem, because the controls within your battery-based inverter are keyed to the voltage of your battery system. So once the battery reaches full capacity, it's going to shut down your inverter. It's going to turn that thing on and off based on voltage within the battery. So
or a lot of them will shut down the generator.
Yeah, it'll shut off the generator, or it'll kick it on when the batteries reach a certain predetermined depth of discharge. So it's the battery that it's keying off of to control the generator. But if there is no battery, even just a small battery bank, you're not going to be able to do that with your generator.
I would think, I always think that you can't really do it without a battery efficiently, because you're going to have fluctuations. I would think that would be the same reason they're telling you to cut the generator off from the panels, because if the panels go up and down, the generator will rev up or go down. It can't keep up with the fluctuations of electricity. It'll be screwy.
Yeah, that makes a lot of sense.
If you don't run through a battery, I think it'll smooth it all out.
Yeah, and of course, the bigger the battery, the more capacity you have to even that load issue. One of the issues with the IQ8 that they've discussed is essentially, as you get clouds moving in front of the sun, then certain loads are going to be disconnected. Your whole system's going to shut down if you're trying to pull more power than is available through the system. And they say in their advertising material, yeah, you can set it up to prioritize your loads so that they'll come on sequentially, at the circuit level or whatever. But that seems like kind of a dodgy way to run a fruit cart there. I think you'd want to just incorporate a couple of batteries anyway to keep that even. But who knows, as the technology improves, So any comments? I know, Don, you've got a lot of experience with the generator there. I don't have much experience with generators except, the pull start ones where you plug something into the start of it. But anybody else have any comments or concerns on it?
I just had a question. So how does that play out even if you didn't have a generator? So I have the sun going during the daytime. Am I going to be going through the battery so that the power is smoothed out? Or do I want to save my battery once it's full and use the daylight to run my load and then save my battery for when the sun goes down?
Sure.
How does that work?
That's something that you can determine, with load management systems, and these load management systems are getting pretty granular. You can manage down to the appliance, with these smart plugs and the like. But in the past, normally you would have a critical load panel and you would have your main load panel, and then your battery plus array would service the critical loads. And you would manually control that by turning things on, turning them off to extend things as you wish. Now they've got circuit level controls, they've got plug level controls, where with your smartphone, you can actually remotely turn on and off loads, because you might be at your office and you get a notice that your home has experienced a power outage. And you go, oh, okay, well, I don't want to drain down my battery running my air conditioner all day long. Let me shut that thing off, and I may as well shut off my hot water heater because nobody's there to use it. And this way I can extend the life of my batteries into the evening. So that's kind of where we're moving towards, is this kind of load management or demand response network at the appliance level, either automated or manually controlled by the consumer. That's going to be interesting, and it'll all be programmed through your phone.
Hey, Jay, I don't have quite the application you're discussing. I've got an off-grid system with Outback. They do have a grid tie feature, and the inverter manages all the loads in that design. So it assumes, though, that you have batteries, and the inverter decides whether it needs the generator or whether it needs to take power off the grid or whether it uses battery power. The only other thing I was going to mention is an interesting thing for me when I designed the system that I didn't think about is that Outback recommended that you size the generator for double your load, double your typical load. And I hadn't thought about that, but their reasoning is that you want to be able to fulfill your demand plus charge your batteries at the same time at a level equal to your normal load. So anyway, just thought I would pass that along to share that.
Yeah, there's also, it just reminded me when you're talking about sizing constraints, there are some sizing constraints if you're doing a AC coupled system, where you have an existing array, and now you're wanting to incorporate batteries with a battery based inverter charger. Because in an AC coupled system, when you're retrofitting, you're basically adding another inverter charger to the system. So you're taking your AC output from your array through your grid tied inverter, then directing it into a inverter charger, which converts it from the AC to DC to charge the batteries, or takes the batteries and converts it to AC. But there is some sizing constraints that the battery-based inverter charger has to be enough. They recommend at least 1.25 the size of your grid-tied array inverter, because you're going to take all of the power from the grid-tied inverter, and you may also be getting some power from the batteries. So it needs to be oversized, sort of like we do with NEC wiring codes, just to make sure you don't overpower that inverter from your array, because there is that variability of sunlight as well. So yeah, there's lots of those little things when we start getting into the complexities of an AC coupled system or a DC coupled system. And more of our systems are getting installed using that technology. So it's something I think we need to pay more attention to. The simple grid tied array that used to be the norm is no longer the norm, especially when you start integrating electric vehicle bidirectional charging with battery banks and generators and microgrids and, virtual power plants with the utility, and cyber attacks from Russia and everything else. It's going to be, it's an interesting mess. So
It's a brave new world, Jay.
yeah.
Great time to be alive, Jay. It's a great time to be alive.
Yeah. lots of interesting things. It's nice. It's a sign that the industry is maturing. Now we've got adult problems to deal with. It's that kind of thing. We're no longer just worrying about how are we going to turn on the light bulb. So
I can't help stop thinking that when I talk to people about putting a solar array in, the first question they ask me is return on investment. How long is the return on investment? And quite frankly, I don't have a generator in my system because where I am in Ohio, the bottom line is if the power goes out, I think the worst I had is like 4 hours.
Yeah,
And I can live with 4 hours without energy. So you start talking about a return on my investment by buying a generator and all that kind of stuff. I'm never going to be able to pay that back, never in a million years. So for me, it's just better to say, okay, I'll take my system. If it goes down for 4 hours, that's okay. I can live with that. You guys keep talking about all this stuff and all I keep hearing is cha-ching, 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 cha-ching. You're adding more money, more money, more money. And right now, that is what I'm finding a lot of people I'm talking to are saying, well, I need to know what my return on investment, how long do I have to pay this back, blah, blah, blah. And I don't know. So, I mean, now you start adding this more, you're going to turn a lot of people off.
I'd say
Well,
it's
I
really
think-
insurance.
yeah, there's a difference though between a residential need.
Yeah.
And I've been doing some site evaluations for some commercial properties. And you start, like I went and did one for a chicken facility where they're raising chicks, fertilized eggs for resale. And they cannot be without heat, water, power. Otherwise, their entire operation just shuts down. So they've got big generators there backing it up. Or a dairy that I just did, or a grocery store that has, the frozen foods department and those kind of things, which is you do a hospital. All of these things have different needs than they could not survive a 4-hour power outage. They
And
just,
I'm sure there's always exceptions to the rules, but
yeah.
the general reasoning for most people in the public sector is, I just don't want to spend the money.
Right. No,
Yeah.
and I agree with you. And we have not had backup at our home for that same reason, because it didn't make financial sense. But we're seeing largely in some clusters like Texas, where they had the problem, long period outages because of the winter storm, Puerto Rico with the hurricane, California with the wildfires. When you start experience 1 week or 2 week or 3 week power outages, people start being motivated to incorporate some sort of battery backup or generator system.
Yeah.
It doesn't happen much in Ohio, but if you remember Hurricane Ike, I was in Dayton.
Sure.
People were out for 3 weeks or more. Not not most of them, but
I remember that, yeah, but those are anomalies.
it's an insurance policy if you're on the grid.
Yeah.
It's just an insurance policy. So a lot of people that don't have solar have generators for that reason.
I know that. Just a lot of the blue collar people I'm talking to, they can't afford it. I mean, they're looking at the money to buy the system itself. You start adding the generator, which is adding significant cost, that turns them right off. They just,
Mhm.
and we're trying to promote this, right? We're trying to get people to do this. And somehow we have to make it as cost effective as we possibly can, just to ensure that they're going to do this. And so I think that's what we need to do, is come up with a system that is the most cost effective with the least amount of thing, really. But that's the marketplace.
Well, I have a question for you guys. Maybe somebody here has a good notion on this. As I said, I've been doing some commercial evaluations, and some of the systems that I'm looking at are sizing up pretty big, like 150 kW systems. And one of them, this machine shop I was just doing, was around 150 kW, but it's 240 three-phase. It's a 240 three-phase delta system. And so I was trying to figure out point of connection to the utility. And how is that going to be handled? Because normally with a residential system, let's say you've got 30 kilowatt system, and you would just simply divide 30 kilowatts by 240 volts. You end up with whatever amps that is. Trying to figure in my mind, what is that? Maybe 150 amps, somewhere in there. And then you would make your connection, and probably a supply side connection or whatever, because you've got 200 amp service coming in from the utility. But 150 kW, at 240 volts, that's got to be some big wire. And is that,
Jay, I've never heard of three-phase 240.
yeah,
480.
yeah, 480 I'm used to, and 207 is pretty common for smaller three-phase, but 240 is a thing. I know it is a thing. And it must just be because of their machine shop situation, the equipment that they've got in there. Who knows? Maybe it's German machines, or whatever. But I'm just wondering, and it makes logical sense to me that whatever power they're currently using, the wire that is coming in has to be sized to provide the amps that any array that's going to meet that power would potentially export to the grid. That makes logical sense to me, but when I look at some of these wires, it doesn't look that way. Now at the machine shop, I would say the wires coming in were the size of my arm. Those things were pretty massive, but like a dairy that I looked at that was about 130 kW that they were going to need, those wires, I think he told me they only have 200 amp service, which I just can't believe if they're using that much power. But who knows? Maybe it's just even load all the time. So.
Is it just, Jay, and I don't mean this bad, but if it's a dairy, is it kind of out in the country where, I know where I'm out in the country, I don't get inspected. Electric.
Yeah, but this is one of those that, you don't pass inspection, that's one thing, but if you're taking more amps than the wires can handle, that's
Well,
a thing.
I would think, yeah, but there's usually a safety factor in there,
Yeah.
which is necessary, but people might be skating it.
Okay, well, I'm going to do a lot of research on this to see exactly what's required if you're wanting to hook up a system like that, because clearly that requires a lot more cooperation from the utility than just a residential or a small commercial property.
So with three-phase, Jay, would you have 3 transformers on a pole?
No, it was just a simple, single transformer up there. I think that's fairly common. You can have a 3-phase transformer or a single-phase transformer. The wire that's on the grid is going to be 3-phase until it gets to that transformer for the most part. So then it's just, going to be forwarded on. I think what's pretty common with some of these is a step up or a step down transformer that gets added, like a ground mounted transformer, to take the power from your array and either step it up or step it down to meet the grid requirements. So that's another thing that is not something I'm not familiar with, but I have seen installations that have ground mounted transformers. And the building I'm in right now, the power comes in at 470 3-phase. And then there's a big transformer that transforms it to 207 120. So because they have some 207 3-phase loads, but then most of it is just 120 single phase. So there's a big step down transformer in the equipment room here. So I think that's fairly common, but not quite sure. And another thing to learn. So as we get into these bigger systems. And then I guess another thing that's happening out there in the world is oftentimes people are just doing they're doing commercial direct to grid connections, bypassing their utility or their own load, and then doing essentially what amounts to a power purchase agreement with the utility. So they're selling it directly to the utility and then buying back from the utility. So, so there is no internal connection. It's just straight to grid. And so I'll see where that seems to be appropriate and where it's not. Because I would think the grid's going to get something out of that for sure. So
Jay, when they do that, when they connect direct to the grid, do they just hook right to that transformer that's on the pole?
usually, of course, with a power purchase agreement, you're going to be hooking into some higher, not necessarily part of the distribution network. It may be part of the transmission network. But they will, the utility will come out with a separate transformer, and you just connect straight into that transformer. So,
So you probably have to be in an appropriate place.
yeah, yeah,
So for instance, in our house, we don't have any 3-phase. We just have single phase here.
yeah.
But up the street, because there's a dairy up the street, I don't know, it's a quarter of a mile. 3-phase comes to within a quarter of a mile of our house. Then from our house further south, it's all single phase.
Okay. Yeah, I would think that a situation, let's say that Google wants to put in a data center and they're using massive amounts of electricity. It may be wise for them to just simply put in a solar array that connects directly to the grid and then feed their multiple buildings off of the grid. And that may make financial sense rather than to try and integrate it within their own network. That may be an example where they would just come to an arrangement with their local utility. Okay, we're feeding you in this amount. We're going to be using this amount. Let's work out a pretty equitable deal as to what we get out of that. So that's where I figure that's going to come into play.
I think we had something similar to that at our company, Jay. We did this with the Delaware utilities. There's only one utility in Delaware, if I understand, but they put up covered parking for us.
Uh-huh.
Because they had to have so much, and they gave us a fairly good deal because they had to have so much renewable energy for their portfolio by the end of X year, whatever year it was. And but I don't think we feed directly off of it. I think it feeds into them, and then we feed normally back from the grid. I don't think they change any of our connections.
Yeah, makes sense. Okie doke. Anybody else have anything to add before we call it a day?
I want to throw in the total layman question in what you're just talking about. All the regulatory stuff, are consumers residential paying for the infrastructure for industry or vice versa, or do they really keep those separate ledger books?
You mean as far as the utility, does the utilities do consumer subsidize industrial use, or do?
Well, the 3-phase things you're talking about, which
Oh.
require separate wiring and equipment.
Yeah, I think it's pretty well, oftentimes like the utility or the end user will have to pay for the upgrade of their transformers and things like that, even though they don't own them. So I don't think there's any subsidy going on where one market segment is intentionally, I'm sure there's some slop, but no, the costs are fairly well allocated, I would assume. In fact, even with residential customers recently, I've heard of situations where they want to put in a big solar array and the utility says, well, the transformer that's serving you won't accommodate it. If you want, we'll swap it out, but you're going to pay the cost of a new transformer going up on your pole. So, you know, that would be, I'm sure when you would build an industrial facility, you have to cover some of the service entrance costs from the utility. So, and we talked about a couple of weeks ago about the delays in interconnection of these larger systems. So that might be a nightmare as well, where, you know, it may delay your project 2-3 years to get that approval for interconnection. So.
Yeah, I don't know if we talked about this before, but when I was out in California, the timeline given to us for the average wait time for a DC fast charging station and EV charging station was 18 to 24 months from
Yeah.
the time you say I would like until the time you can charge your vehicle. 2 years.
Yep. Yeah, we touched on that because I think and it's getting worse.
It's getting worse.
all the
Yeah,
time.
absolutely. So that's what, you know, this is like super niche, but that's where we're starting to see some interesting traction on our side of the house of like, hey, how can we get around this? How do we do, you know, use solar? I suppose it could be wind, but solar direct to charging, de-scope that entire timeline. I mean, we're seeing some kind of wacky ways to solve this, right? Like I went in Santa Monica, Tesla's solving this by putting several flatbed, like 18-wheel trailers on empty parking lots with huge ass batteries, and their DC fast charging stations connected to those batteries. And they roll them out, drop them. People charge their Teslas, lower the battery down, they pick them up, take them back, refill them, right, and they just swap them. And that's the way Tesla's solving this problem, because they're like, look, man, I'm not going to wait 2 years for a charging station. That's insane.
Yep. Well, just don't do this in Wisconsin, because apparently.
Well, unfortunately, like they're like all of the shady characters are coming out of the woodwork now that the EV genie's out of the bottle. And now that solar looks like it's, it's not a hippie fringe technology, right, anymore. It's now affordable for the masses. And we're seeing nationally, we're seeing a lot of bad actors, trying to claw and go kicking and screaming into the future. So, I get personally a little kick out of making them, kind of relics of the past, because like you're either on board or you're not, man. And if you're not, watch out.
Yep. Well, this is very much a technology that's going to separate the folks who know how to use a computer from the ones who decide that the typewriter is here to stay, and
right.
I
mean, for us, it's really unfortunate because, we talk, I try to avoid it whenever possible. We do a decent amount of communication with utilities. And some of them, the really progressive ones, realize that specifically electrification is a huge, it could be a big challenge, because at the end of the day, utilities are tasked with keeping the lights on 24 hours, 7 days a week, no fail. But they also, just kind of the way that the utilities created, being geographically constrained in most cases, for years, they haven't had a whole lot of options on how to, expand. And EVs, a lot of us thought like that would be the key to unlocking like a little bit more creativity in the utilities, because now it's like, oh my God, we can capture all of those electrons instead of going to gas stations. Now that they can come to my geographically constrained territory, and this is going to be a boom, and utilities are going to love it. But like you've, I think, done an excellent job pointing out, man, some of these guys are dinosaurs, and they are fighting this tooth and nail, and it doesn't make any sense to us.
Well, I still believe within a decade, the largest utility in the world will own no infrastructure whatsoever. They will be a virtual utility and unconstrained by geography. So, that's
probably Apple or Meta or Amazon. Yeah,
I was gonna say, wasn't that Enron, Jay?
They were.
No, they were not constrained by any morals.
I thought they met that definition, Jay, already.
I don't know about electric, but certainly natural gas. Yeah, I think you're probably right, though. I mean, they might have been considered that. There's no reason why we won't see people. Already they're subcontracting out. They're subcontracting out generation. They're subcontracting out transportation or transmission. Why not subcontract out distribution? And now you're just simply a clearinghouse connecting customer with supply. And that will be the marketplace for the utility of the future. And most of the utilities that we currently have in place will just simply be distribution companies. There'll be people who deal with that last couple of miles. And they don't go away, but they will rent out their capacity to other players.
Jay, it's like the oil division. Marathon used to be a fully integrated. Now there's refining and exploration and stuff is separate.
Yeah,
you're breaking in pieces, taking all the pieces of the function and breaking them apart.
Yep, it'll be interesting. So we'll all be working for Tony someday.
I mean, Jay, I think you're 100% right, right? Like, and that sounds an awful lot like a software company, right?
Yeah.
Like for those of us keeping score, someone that's really good at connecting multiple decentralized distributed nodes and doing that energy connection, energy marketplace, energy, matchmaking. That sounds a lot like a software company, not a utility.
Or social media. Social networking. Well, already Google, Apple, Amazon, Walmart, what are some of the other ones? All of these have gotten federal approval to be utilities. So, they're moving into that marketplace. They're going to be the ones And my guess is this industry is going to change so fast, maybe they become the dinosaurs. You know, somebody in a startup is going to look at Apple and say, oh, those guys just plod along too slowly. I'm the one that's going to take over, and it's going to be two geeks with horn rimmed glasses sitting in a garage somewhere in San Francisco, you know, so.
I seen an interesting video the other day where the trucking companies who have electric trucks, instead of plugging them in, they're creating battery stations where you drive the truck in and the one battery slides out and another one slides in and they continue
Yeah.
on. So they don't have to plug in, they don't have to wait, they don't have to do anything.
Yeah, that's an old concept. I know there was an Israeli company that was looking at doing that. Yeah, there are problems with that, and there are certain applications where that may be the right answer. But
But this is a huge trucking company, so.
Is
yeah,
Denmark,
if it's
isn't Denmark doing that or Denmark trying to do that?
Yeah, I mean, but battery swapping's, kind of a global thing that people are trying. At the end of the day, the battery still needs charged, right? And it's in depending on who's making the battery for the thing, it differs how you take it out, right? So it's like, it's not as easy as, well, you just walk up to a battery swapper and it swaps it. It's like, well, if your truck's made by someone else, then you've got to make sure that any one of your automated, because it has to be automated, battery swapping technology can work with any EV manufacturer, right? And that's kind of difficult to do.
Well,
and that's why we've kind of seen it slowed.
If batteries are 25% of the cost of an electric vehicle, man, you talk about warranty issues. All of a sudden I had a good battery and now I got a crap battery.
Exactly. Yeah.
Yeah,
Jay, exactly. And it's not only the warranty, it's you need more batteries per car if you go with battery swapping, which is why it's never taken off, right? You need 2, 3, 4 EV batteries per EV if you go with the battery swapping model. And that's, that economics math doesn't pencil, which is why it's never taken off.
But if you're a big trucking company, you can specify the batteries and the connections and all that in your purchase.
If
And
it's
then-
internal, if it's an internally controlled system, that's a different thing, I think, than
Or you go to megawatt charging. So I'm on a working group with Argonne National Laboratory that's developing kind of the megawatt charging standard. And they're just like, or you just push more energy to the battery and charge it much, 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 much faster than anyone else is talking about. And that seems to be like the way that the industry is going to go, is like,
Do the
rather
current
than take
batteries-
out like we're talking about like tons of batteries, right? In an 18-wheeler's case, it's like, or you just push a tremendous amount of energy to that battery, and then you have your solution. That's what Argonne's working on. We're actually writing the standard for megawatt charging.
Do they have to come up with new batteries for that, or could the current batteries handle that?
Current batteries can handle that.
Okay.
I think when battery conversation hits even us nerds, it's already like it's months or a year or two behind what's actually bleeding edge. So a lot of the work that I've been doing recently is like figuring out what bleeding edge is. And like BYD, for example, they've already come up with $89 a kilowatt hour battery, right? So it's like all of these like, oh my God, they're made from small Congolese hands in cobalt mines. That's like a five, like we solved this like 3 years ago. So it's like all of these things are like everyone's like freaking out about now. It's like that's been solved 3 years ago. What are you talking about? And that's been really refreshing, right? Like so many things about how we recycling these, child labor, like, all right, that might have been concerning like 3 to 5 years ago. That's not a concern anymore, right? And that's been really eye-opening on my side to be like, oh, nobody actually knows what's going on, because the people who are actually making batteries have identified this from day one, and they've taken active steps to reduce the cost, reduce the size, increase the cycle, the cycle rate, the life, where these minerals are coming from. Obviously no one wants to contribute to child, slavery in any part of the world, right? So a lot of these things that people freak out about have already been solved. These are solved problems.
I would assume once the car companies got into it, they would be sourcing only from the good places, because otherwise they can't sell their consumer, giant consumer goods.
Ford already does that. Ford already does that as part of the commitment from their suppliers.
Okay, well, why don't we push off, I'm gonna call it here, we're already a bit over an hour, but maybe, obviously, we'll want to talk about batteries in another session here. So why don't I put that on the future schedule, because there's just so much to talk about. Make sure
Yep.
Tony's on the call for this, so, all right.
Thanks, guys. Thanks, Jay. I appreciate you.
See you
Thanks,
guys
Jay.
in 2 weeks, all right?
Can
Thanks.
can I
You
hold you on
guys.
for just a second, Jay?
Yeah,
I have a question about your high tunnels. It's
Okay.
not solar at all.
okay.
If you can stop the recording, I just wanted to ask you a quick question.
All right, yeah, let's see, how do I stop? Yeah, there we go.